Hey everyone, welcome back to Makerspace CT. It's a new year with lots of changes, and we're really excited with what's going on here at Makerspace CT with classes and programming, from our wood shop to laser cutting to our textiles. We have some youth programs going on right now. In addition, we're starting to put together our summer STEM initiative for our high school students. So over the summer, we're looking at 8 weeks of innovative classes and really cool opportunities for students to get involved in VR, Arduino programming, as well as Raspberry Pi, and get the students in here playing with innovation and having fun just like we do every day. If you haven't seen them up on the highway on I-84, and I-91, we now have billboards advertising Makerspace CT. And it's all about igniting new technologies. And you'll see on the billboards our new CNC plasma cutter right there on a 14 by 14 foot image. So be careful, don't get in an accident, but take a look. It's really cool. And we love marketing and talking about the great things happening here. So some of you at home already know this, but we have 2 MIG and TIG classes each week. It's an opportunity to come in here and get an introductory lesson on welding and then step it up the week later or a couple weeks later and go from MIG to TIG. And I'd like to introduce to you our certified welder and really amazing instructor who's been taking everyone on these journeys. Here's Sabrina.
Thank you, Mark. Thank you. Hey, everyone. Thanks for coming live with us today. We'll have a really cool demo today. We're going to do a Logan Steel weld table. We're going to go start to finish, and we'll go from there.
Would you like a picture of the Logan Steel table?
Absolutely.
Here you go.
Little blueprint here. And if I'm not wrong, all these pieces were cut at Logan Steel, brought to us here, brought to our space, and you could purchase this yourself and bring it into the space and weld it here. We weekly run classes. Besides that, the space is open to your exposure. So here is the weld table itself. Have all our assembly pieces already cut and laid out for us today. So we'll go ahead and get at that. We'll start with a look at our MIG welder for the day. We're going to use our Lincoln Electric Power MIG. Come on to the front and flip it on. Allow the shielding gas flowage. Once the machine turns on, it will give us our digital screen and we'll set our parameters for what we'll be using today. All right, now that is all set up, I will show you what we have laid out for us today. If you look at the blueprint here, it gives us our parts. Most of it is square tubing. We have 2 by 2 and 1 by 1. Quantities of 4 pieces each. All pre-cut to size, all cleaned up and ready for us to get it added. So the first thing I'm going to tackle is the leg pieces. If you look at the blueprint here, they are an adjustable leg. I modeled one up for us already, giving us that nice adjustable feature. Have them all laid out here, and I'll weld them all up in a second. So the way we're going to do that is just mounting them here, allowing the bolt to go just about to the edge of the plate, just so it's not hitting the table. Get that nice and square. And tack weld in 3 spots. Now it is important to, when you do this, to do in a sequence weld. You're not going to weld one right next to each other. You're going to weld one on one side of the octagon and one on the next. And there you have it, an adjustable leg. Do the last two. Another leg. And our last adjustable leg. Now the next step would be to make our modern H-leg side frames. Looking at the blueprint, that would be here and here. Now to do that, what I did was I mocked out what it would look like. I put my longer square tubing against our flat tabletop to give me a square edge. Put the side piece that provides support, pushed up the side of it, put my square right up nice and close to both pieces. With the blueprint, you'll already know what the dimensions are, but this square tubing is 36 inches long. Our side supports are just about 17 inches long. So from there, I marked out about halfway in between each. For the distance up the side that the supports will offer, I just have cut out pieces of steel just underneath that piece, bringing it up a little bit. Check squareness, check level. Looks all good there. Now, same thing here. We're just going to put a couple of tack welds. We do not want to do a finish weld at this step now. Two tack welds. Now, the beauty of tack welds is you can always break them off if they're in the wrong spot and readjust. And then we're going to pull up our other side of our H frame. Same thing here. 36 inches long. Find the half point and weld. Ensure squareness. Flip it over and add 2 more tack welds. Now same thing here, we're bringing out the rest of our pieces in. Going to knock up, follow our blueprint, and then we'll move on. So just flip up, Brian.
She has to, I think she has to find something.
Hey everyone, I just wanted to stop in here real quick and say Sabrina's over there doing some grinding, but don't forget, go to our website and check on up at the top where it says learn, and that's where you can sign up for all of our classes. So don't forget. Back to Sabrina.
So when getting cut on the jet saw or circular saw, anything like that, you will come across some burrs. We just want to get rid of those to eliminate any misleading measurements. Tack weld this side again. And like the last one, flip it over, 2 more tack welds to the other side. All right, can you break for a second? Sorry.
Sure.
Cool. Roll it into something else, and then I'm just gonna get everything framed up for the next step.
Okay.
What you thinking? How's that rolling? Do
This
we have
looks-
any viewers?
This looks great. Yeah, there's a lot of people out there watching, and I think that they probably have some questions about what the levels for, how the magnetic levels work,
Okay.
how you mark things up using a chalk pen. I think that they'd love to learn a little bit more about that as well.
Sounds good. I will add
This
that.
is really great.
We'll roll it. Yeah. Go ahead.
All right, now that we have 2 of our most important pieces for our build tacked up, we are going to add our adjustable feet onto the ends of them. So the best way for the feet is to get them, I found so far, is put the actual H onto the floor, eyeball it so far, and then check with your actual measurements. I'm just using your basic tape measure to do so today. about a ½ inch all the way around. Don't be silly like me and attach the ground clamp. One thing you want to just make sure is that it does stay flat. Because when you tack weld one side, it is going to pull the other side. To fix that, could just give it a little whack with the mallet. And that just about does it. So like we mentioned, roughly about a ½ inch. Now our ground clamp is on our actual workpiece because we are no longer on our metal workbench. Same thing here, we tack weld one side. And it lifts the other side. Move this set of cameras off. Grab our next set of legs. Same thing here. We have our side of our H-frame, and we are going to add our feet to that. Check both dimensions. Put our proper PPE back on and throw some more tack welds. I said it last time. Don't be like me, guys. Put your ground clamp on. So from the top, center them as best as you can. Get your fine print checked with your actual tape measure. Swap sides and do the same to the other side. Dial it in nice and close. Now we sequence weld because of multiple reasons, the main reason being heat distortion.
Okay.
And then I'm just gonna get it up to the actual tabletop and then.
Okay. There you are.
Okay, so up next we will be adding our legs to our actual tabletop. These magnetic squares are going to be your best friends with projects like this. Voila, as simple as that. One way you can scribe your dimension lines is with a Sharpie or piece of stone. And no way much for or a piece of soapstone. Sharpie, on one hand, will contaminate a weld, whereas a soapstone, you can weld right over. I'm going to start positioning our legs 2 inches in from the outer of the topper. And to just ensure your work is actually square to your pieces of metal, use a square like so, abut it to an already square edge, and test your tubing out. Same thing here, sequence weld, we will finish weld in the end. All right, now those are tacked up. Same steps as last time, you're going to mark it up to the edge, use your tape measure, and mark your dimension. A couple of tools we'll be using. And still 1.5 from the edge. Use your square again. All right, put your proper PPE back on. Now, when you're welding types of joints like this, your gun has to be pointed at a 45 degree rather than a 90 degree, 15 degree travel angle. You have to focus on penetrating both the base material and the parent piece. Feel free, if your tip ends up looking like something like so, with a little ball on the end, just to trim it off before you continue to weld. All right. Now all four corners are tack welded. Our next step would be to add our side pieces. We can run something else. We can run another break.
Okay. You got dead air on now. You want to step in?
So I hope you guys are learning something here with this quick demo. I just want to let you know that our partnership with Logan Steel down in Meriden is wonderful. They have something called a bargain barn, and you can go there and you buy steel for pennies on the dollar. Really, it's a great deal. If you go and you show your Makerspace ID, you will get 27% off anything in Logan's bargain barn. This table you can purchase for around I think it's about $100 for the kit, and you can buy it as a flat top, or the one we're building has a curled front lip and a rear backsplash. And I chose that one because it's a little stiffer. When you put a bend, or what we call a break in steel, and create that angle, you actually increase the weight capacity on that surface. And that goes for anything. That's why metal corrugated roofs are exactly that. They're not metal flat roofs on a house or a barn, because they wouldn't be able to hold the snow load. But once you crease that steel, you increase its capacity. And that's what's wonderful about this table. We'll probably put over 1,000 pounds on this table easily. So here comes Sabrina with the crossbar. She's going to tack them in place.
Modify this one more.
Okay.
All right. So same steps as the last couple of things. We're going to use our tools, meaning our couple of magnets, level, soapstone, Our level is a good tool for fabricating because you always want to ensure your pieces are square. Welding requires a lot of heat, so heat input into our fabrication piece will distort. Wow, couldn't have got that any more perfect. All right. Same thing here, sequence tack. If you need a little bit more, you don't need, just pull out your machine. And same thing on the other side. Let me see if I can readjust a little bit. This piece underneath was just added because we do have our curled edges to add more support. I wanted to get the table just a little bit more flat. Eyeball close fit. Use the tape measure to find your dimensions. Check with our magnetic level. And perfect. If you change anything, always just throw your level back on. And Tack Welds. One last one over here. All right. Now the basis for our table is all put together. We're going to pause for a second, put it on the floor, and then we'll do our finished welds. I could probably do it all on the table now that I think about it.
Are we on? All right. So in just a second, you're going to see our plasma cutter in action. But we decided to customize our table. And this is just a sample. You're going to see the real one cut up in just a minute. But our plasma cutter is a little bit like a laser cutter. A little less accurate, but it gets the job done when you need circles, custom pieces made. Let me show you a sample. If you were to make this here in the shop, that would take hours and hours of die cutting and die grinding and drilling holes. If you just draw this up as a DXF or in Adobe Illustrator, a vector format file, you can import it here into our Shop Pro software. And when you run the plasma cutter, it's a little bit like a welder because it uses an arc of electricity, and it runs from the electrode through the steel, which is grounded through this table here. And what happens is you create that arc, so you're melting metal. You're creating another state of material called plasma. And what happens is you need to get rid of that plasma, that old metal, that melting metal, and it gets blown out using air. So that's called slag, right? So we want to get rid of the slag and get it away from our part as we're cutting. So there's a couple things that have to happen, right? You have to choose the amount of electricity, the amount of amperage, depending on the thickness of steel. The thicker the steel, the more amperage you need to get that arc of light, or arc of electricity to bore through the metal. And the amount of X and Y travel is important as well, because you can't move too fast, you won't cut all the way through the metal. If you move too slow, you end up burning the metal and creating too much of a hole. So the software figures a lot of that out. If you put in the thickness of the metal, the gauge of the metal you're using, and So what we're going to do is we're going to add to Sabrina's table over there. Not only is that going to be a useful table in our shop, but we want our members to know where you can purchase this table and the fact that you can weld it right here in Makerspace. So we wanted to make this little advertisement here. Again, this is the first sample. It was still cutting the maker, but I wanted to stop it so you could see. So it says right here, purchase this table kit at Logan Steel, weld it here at Makerspace CT. This font is called stencil. Maybe it's not obvious, but when you cut with plasma, you end up losing the centers of A's and O's and R's. So you create a stencil font, you use a stencil font, and it links the hole for the center of the letter to the substrate, so you don't lose it, so you can still see what the letter is. In this sample, there's a good example of here. Right here we're missing, is that an H? The H is missing the center because the machine was running just a little too fast there. But Scott's going to roll a video right now, and you're going to see this part being made. The idea is when it's complete, it's actually going to have a curved top, and this will get welded by Sabrina to the backsplash of the table. So roll the video, Scott.
So to finish weld today, we're going to look at our actual requirements. We're using mild steel to look at our wire feed. Our spool is .035 carbon steel. The reason for that being, like I just mentioned, we are welding mild steel today. We're not welding steel, stainless, aluminum, anything like that. It's a .035 wire. For my motion, I'm going to bring it right over to the camera. Your stick out wire is going to be just about 3/8 of an inch from your gun. You're going to have your gun. The best way to do it is prop yourself up. Whether you're welding at a 90 degree or a 45 degree, you're going to prop your hand up. And the motion that I do is a pull method. And I also do a clockwise while I'm welding. So if you get the camera nice and close, I'd start on my tack weld, give it a second, and then continue to move on. Slight motions, just like so, letting the weld penetrate, but also moving down my entire weld. When you're MIG welding, you do not want this tip entirely buried into your piece of metal. The collet holder itself will weld shut, and you'll have a little bit of a mess to clean up. But I'll give you an example of that right now. Just like so. Now, when you get in situations like this over here, you have a little bit of a tight joint. You can give it a little bit more stick out, but just get your positioning right. The most important thing is comfortability. Now, there's a couple different methods for MIG welding. Push-pull method, drag method, any of those methods will give you a good weld. Now, it's important to keep sequence welding. Do a couple more around here. And keep jumping around until you finish weld. Like I've mentioned before, if your tip gets a little bumped up, clean it up just to give yourself a nice fresh weld start. I keep cutting the camera off. Leaving my tools behind. A couple more over here. I'm still using my clockwise O, if you will.
Hey, can we pause for just 1 second, Sabrina?
Absolutely.
We have a question from one of our viewers. His name is Troy. Troy, your question was, is this a table that you saw a print floating around here? Absolutely. Actually, Logan supplied us this table a few months ago, but we've been deciding where we're going to put it and how we're going to use it, and we thought that this is the right time to step forward. So yeah, we've had this table kit here for a few months, and the print has been floating around the shop, so this is the one you were thinking. So
Yes,
take it
it
away.
So we're still going to continue to finish weld all the way around our entire table. Keep going from there.
Hey there. We live? All right. So while Sabrina's laying down the final beads on that table, I'm going to take you over to some of our metal working tools, some of our hand tools, and just run you through a few of them really quick. Is that okay? All right. We good? Some of you have seen this deer. This is the deer we did for Envision Fest a year ago. It was a community project, and she's still floating around. If someone could find a use for it, we're all ears, or antlers. All right, so if you've been in our shop before, you know that Stanley Black & Decker has been gracious enough to support us with lots of Dewalt and Craftsman equipment here. And I'm going to just show you a few things here on the shelf, and I'm going to take you over to the workbench behind you. And I'm actually going to operate some of these tools and show you what they can do. We thought it was appropriate to talk about these tools since we're in the Metal Fab Shop anyhow. And we want to let Sabrina take it away over there with the welding. But let me show you a few things that we have here. Some things brand new that just came in the last week. We now, because you asked, we now have a 4-bank battery charger here. It charges right down to the smaller 20 volts up to the larger 60 volt amps batteries. And sometimes you're using these larger batteries with the larger metalworking tools as well. It's not just a simple drill. Sometimes you're grinding and grinding for 5-10 minutes. So you really want the power behind it. Also, we use this as a portable power station. Believe it or not, you can unplug this from charging, turn this on, and it gives us about 120 volts continuous power when we use a mobile video station like the one you're on right now. So we just installed one of these here in the Metal Fab room. We put one in the wood shop, and we're about to put one in the machining center as well. So thank you, Stanley Black & Decker. Thank you, Dewalt. We're thrilled to have it. So everything you see up here on the wall is typically used here in the metal shop. That's why it's here. And let me put this down. This is a carbide tooth 4.5-inch circular saw for cutting steel. A lot of people think that this is for wood, but it's a little heavier gauge machine for zipping through some lighter gauge metal. And then we have some corded tools as well. This is a die grinder. A die grinder is typically used for rounding edges on steel, taking down an old weld that's not working for you. But it looks like Sabrina's got that one under control. She's not going to need this today. But I typically do when I weld. My welds are a little messy. This will take care of it. Also, from the plasma cutter, when you come from the plasma cutter, you get some sharp edges on the back of that metal. You can use this nice flat surface on the die grinder to smooth things down. Next, we have a wire brush wheel. Nice for shining up metal before you weld it, prep it, clean it. We have a variety of wire brushes. These are like these spinning Brillo pads that get a little bit more of a bite than a wire brush. Die grinding wheels, sanding wheels. We also have, here's an example of what I think we call them flapper pads. It's like these pieces of sandpaper that are layered on this wheel. And it's great for really taking down messy welds, getting metal right down to its raw finish. Sometimes in the art world, an architectural area, you'll see someone will take a flap wheel like this and they'll run in circular motions. And you'll create this really interesting effect in the steel. And when the sun hits it, I think some of you have seen that, you see these weird spirals. And it's pretty cool. Almost looks like the heads, the valve covers on a 1960s Ferrari, which I really dig. A Sawzall. Sawzall is a pretty basic tool for cutting through some steel pipe. Usually a heavier gauge. You don't cut thin gauge with this. We have these nice quick change blades. By pulling this back, you drop the blade in there. You only change the blade when the battery's out on this tool. You never change it while it's in, even though there's a lock feature. Safety first here at Makerspace CT. In addition, we have plenty of drill bits. We ask here at Makerspace that everyone returns the drills to their proper place. Our shop manager, Aaron, will find you if they're not in the right place. So please do that. We also have something called step drills. What's a step drill? Well, sometimes when you need to really open up a hole into a much larger diameter, and a regular drill bit like this will get you started, a step drill takes you to the next step. Exactly. This set is by Irwin, and they assume you're going to start with a 3/4 inch hole, and this will continue cutting right up to a 1 3/8 diameter hole. Very handy when you need to cut a large hole and you don't want to use a hole saw from our wood shop. You want to use a step drill. We have a variety of those as well. Of course, we have cordless drills. Sometimes it's hard to drill, getting up inside of a tight corner like in here, and you can't quite get the drill in the space. That's why we have a right angle chuck drill. Super handy. And this is a shear. This is a cordless shear. I'm going to show you how to use one over there that's corded. This is used for cutting light gauge steel. If you really need to get it cut quickly and you don't want to use a thin cutting wheel, which I'll show you in a sec, use this, and it's really, really cool. This one's unique because you can rotate this head into different angles depending on how you're cutting and what's convenient. So I'll show you that in just a second. This is what I was just going to show you. Let me show you the difference. This is a die grinder for grinding down steel and rounding it off and cleaning it up. Not to be confused with this, which looks similar, but this is a cutting wheel. Look how thin this is. And notice I'm touching this only because there's no battery in it. This is for cutting nice straight lines. This is a phenolic with a fiber in it. It's only made for cutting a straight line. If you were to turn this, you'll snap the blade and you'll send pieces flying. We don't want you doing that here. This has a nice shroud with a quick release, so you can turn the shroud away from you for comfort and convenience and safety, of course. So you throw the sparks in one direction. Over here, we use this when we built out Makerspace. We used a couple of these for cutting pipe and tubing and conduit. This is a portable bandsaw. This one has the battery in it, so I'm not going to get near the blade, but I will put on my safety goggles, and I'll turn it on in just a second here. It has a lock on and off. It has a variable speed right here, and it's really a bandsaw. See that? Battery goes up here, and this is how it works. Keep it away from me. And look at all the directions you can get. You can go up, down, across. Super, super convenient. A lot of utility personnel, electricians, plumbers will use something like this up in the air on a ladder. It seems dangerous, but they're the qualified technicians to do that. That's why there's a big hook here. It's a ladder hook. can hook it in their belt loop or on the ladder, so while they're going up and down. So that's a great tool to have here. And we do have 2 of them. So let's walk over there, and I'm going to show you some of these sheet metal working tools. Because, you know, when you take a tour here and you get your initial walkthrough, you don't actually see these things in action. So that's why we wanted to really give you guys a well-rounded, quick look at our shop today, at least on the hand tools end and sheet metal work, right? Because today's about sheet metal and welding. I left the clamp right here. So this sheet metal, typically you want to clamp this down for safety. If we don't see you clamping down your material, our shop techs will remind you to do so for safety. I'm going to move. See this stool? It's in my way. I can't have that there because as I'm working, I may trip. I want everything out of my way. Safety goggles on. And I'm going to show you first a cutting wheel. This one's cordless. You just saw me show it over there. Again, it's a cutting wheel, not a die grinder. A cutting wheel works like this. I have it off to my side so the sparks are going to shoot down below here and not get on me. Let me just notice how the wheel's turning this way. So it's running this way, and it's going to shoot sparks down this way. But let me just show you the nice fine line this can cut if you're careful and you keep it straight. So I stopped it before I pulled it out. Now, there's a beautiful straight line here. Again, straight lines only, no curves. If I wanted to bend that, we just got these new pliers in. Basically a vice grip. Some people call it a duck bill. But I can take this right here, grab this thin gauge material, and give it a quick bend, nice and straight. You can put it in a vise and do the same. So let me show you something else. This shear takes about an 1/8 inch of material away. But what's wonderful is this is what it looks like when it runs. So it's variable speed. And what's wonderful is it cuts such a small area right here in the V groove that I can roll this around, and that's where you get your curved cuts. Here we go. So this one looks like it needs a little adjustment. That's strange. Hold on a minute. Let's take a look at something. We're going to have our shop techs take a look at that one. I have this other one right here. A little smaller. Should work on this gauge metal. That's the way it's supposed to work. See that? I think what's happening is this needs a little adjustment, and the blade needs to be brought in closer to these flanges. Again, I'm not getting near that blade because it is plugged in. So, next one. This is called a Nibbler. And it does just that. It takes a little bit of bite out of the metal. As you move along, you're going to zoom in on this one. It's such a small little die. But in here there's a motor, and it rotates like this. And there is an eccentric in here. And essentially it moves this little piece up and down. And this is a small die. I'm going to turn it on. You can barely see it moving up and down. The width of this is just over 1/8. I think it's 3/16. You can change that. And if you look at the shape of this, it's almost like an airplane wing. It's unplugged so I can get closer. This is like an airfoil. The width of this matches the notcher, all right? And then it gets smaller as you go towards the back. So this tool is used in this direction, forward, almost like a little saw, but it nibbles away the metal, and I'll show you how it works. I'm gonna start right here, I'm gonna go forward towards the camera. And it will also pop out the small rectangular bites, and it's gonna put them on the floor, so make sure you sweep up after this. That is a beautiful straight cut, almost an 1/8 inch. And down here on the floor, you'll see all the little pieces that melt. So I'm gonna be sweeping this up in just a moment. You know what I haven't done is I haven't tried to use this in a slight angle. And I'm looking forward to doing it right here on camera. So let's see what happens if I try to make a curve cut with a nibbler. Here we go. All right, so what you end up with a nibble cut like this is a serrated edge, okay? It's a little lumpy. It's not perfect. As I turned, it looks like it got caught on some of the metal here and deformed it. Do you see that in the light? Whereas the shear, when I rotated the shear, it made this beautiful curve like this. But some of these machines are unwieldy. You can't just draw a perfect pencil line and just follow it. It's gonna take time and practice. So that's exactly what we want you to do with your membership, is get in here, practice, and use the tools. Our shop techs and myself, we're not experts on these tools. We know how they work. We know how to use them safely. But it's up to you to gain that experience and come in and really perfect what you're working on. So there's just one more here I want to show you. It's a strange looking shear. So if you've done any cutting with scissors, this one here, it's great to make additional curved cuts because it sends one part of the material under this deck and above this deck. So it's actually pushing it out of the way as you go. And this die moves up and down, and there's another die here. So those are replaceable parts. And there's a little setting here as well. And I haven't used this in a while, but it's pretty new, and I think it cuts great. I think I used it on that reindeer you just saw. You can see where it goes up and down. And that height can be adjusted with this Allen screw. Wow, that cut like butter. This particular cutter really lets you cut sort of wavy shapes. I want to try that again. I've never used it in this on this thin gauge metal, so let's check this out. Just going to slide this out a little. We have clamps all over the place in the shop. If we don't see you clamping down your work, there's no excuse. Here we go, let's try this again. I'm gonna try to do a wave. The problem is this wants to hit the clamp, but I'll try my best. So what's interesting, it looks like it doesn't want to cut that last section off. But that's okay. What we're going to do is we're going to use our cutting wheel and just cut that away. Okay. Remove this from the die. There we go. Look at that wave. I think that's one of the only tools that lets you do a wave like that here. So thrilled to have it. Anyhow, when you take your safety orientation here in the metal shop, our shop tech will walk you through how you basically take material from a raw format and take it down to a finished shape and smooth and workable. And the layout of this shop, if you rotate the camera this way, raw materials are stored over there in the materials area behind the deer. And you cut, you shear, you bend or break. You can notch. This is a notcher here, a foot operated notcher. This is a press brake for bending 90-degree bends. So notice how the machines are large and they're getting smaller because now you're bringing your material down into a more workable format. And this goes for our wood shop as well, where we're using the big saws and we work our way down to the smaller saws and then ultimately the sanders. This is the similar format. Our shrinker stretcher for doing smaller work, our roll for curling steel. We have a couple arbor presses here. Sometimes you have to press a fitting or a rivet, or even if you're working on a bearing or a seal, you can press a bearing or a seal into a housing here. We have a big one and a small one. And then we get down to drilling holes, maybe forming steel into compound curves with our English wheel. And now we have our grinders, wire wheels, our fixed belt sander over there, and then our disc and belt combination sander, and then our large 20-inch sander, all with diamond impregnated sandpaper. So it's all for working in steel. And last but not least, one of our new additions is our Dewalt Radios. I know I sound like a Dewalt commercial, but it's really great to have a little music here in the shop and have some fun. So let's go see what Sabrina's up to and see how her welds are. I think she's almost done with that table. And we'll see you here in the metal shop. Again, have fun. Be safe, enjoy yourself here at Makerspace C. Let's go see. Hey, look, Sabrina's laying down on the job over here.
I'm just taking a nap.
Definitely not taking it out.
Nope.
Wow, what a great table.
Yeah, we're almost done. Is that
Almost
still
done?
going?
So we got to get this camera in close. You got to see these welds. They're amazing. That's why Sabrina does what she does. Should I take the camera or should we just come on down here?
Yeah, I'll do another one too. Couple more finished welds on our table.
Great, I got my mask on.
All right, you ready, Kim? A few more and the table will be all set to go. Got our level on the top and it's all still looking perfect.
It's looking lovely.
Yeah.
Yeah.
And we have just the feet, so.
That's wonderful. I noticed the weld you were just doing with, what's that called, where you're going around in sort of a spiral?
Yeah, so it's actually a clockwise O, like a cursive O, if you will. You could also do a cursive E. I talked about just a drag and push pull, but I love the cursive O. It's just a clockwise O, and you just keep it.
It's a cursive O.
Yeah. Just,
Okay, and then
It is
you
in
connect the
cursive.
next, you connect the,
Yep.
and you're creating a loop at the bottom, coming up across the top.
yep,
and then
watching
down
it
the
fill
bottom.
in. Yep. Watching it all puddle still. It is going to look all like one solid one, but you're still going to get the individual O's in the weld itself.
Cool.
Yeah.
Yeah, I saw it with the mask and I could clearly see the
The movements.
movement.
Yes, yeah.
If you were to put that movement to music, what song would it be?
I know, right?
Think about that.
I will think about that. See, one more over here. When you're welding in a sequence, yeah, you can lose track of where you've been, but you always just want to make sure you final weld every single spot.
And not get distracted by marks. Sorry.
You're good. one more on the ground over here. Now at this point, if you were crafting a table and you reach the corners, the best way to do the corner is a stop and start. There is one fluid motion where you could readjust your hand setting and move it around the corner, or just do a nice start and stop. And when you finish, go about a quarter way over the stop and start right about there. Give it one more glance over. Make sure I hit all the welds. And I'd say it's looking good.
Wow, this looks really great. Can I just say one thing about welding?
Yeah.
I'll show you exactly what I'm talking about.
Look at that. Want a hammer too?
I always found that welding is one of the most satisfying ways to fabricate
Absolutely.
and put things together. And the reason why is if you're not to put down Chip in the wood shop, I'm just letting you know, but if you're in the wood shop and I want to clamp something and glue it, I got to come back the next day, right? When things all dry. If I'm working in fiberglass or plastics, I'm gluing and I'm always waiting for that glue to dry. But welding, it's satisfying because there's this instant gratification.
Yes, same day satisfaction.
Right, and I almost feel like if I had a 2-story building, but I didn't have a ladder, I get a couple bars of steel and I just weld the first rung and I stand on it, weld the next rung and I stand on it, and so on and so on.
Absolutely.
And I can get up to that second story in 10, 20 minutes just welding my own ladder.
Definitely.
So this table's no different. You saw a bunch of parts, what, an hour and a half ago? And now we've got a useful table that'll over 1,000 pounds easy.
Easily. You could attach a vise here. You could attach a electrical strip over here for your grinders, your anything like that. You can attach multiple hooks for MIG wire, MIG, the torch itself, anything like that. This table will be completely useful.
So, do you think that an introduction class, and then if they take your advanced class, someone can come in with one of these kits from Logan and
Absolutely.
just go to town and build it?
Yep, I absolutely feel positive with that. I even feel with the introduction class, you should be able to come in here and fabricate this table all together.
It's great. It's a really strong table. It's here to stay, so come and use it. We may just oil coat it a little bit to keep it from rusting, but you can clamp right to it and weld directly on it.
Absolutely.
It'd be great if we had 2 of them right here, right?
I know, right? I love the height. It's almost perfect.
Yeah.
Adjustable legs. There's nothing you can't say good about this table.
Designed by metal fabricators, welded by metal fabricators,
Yeah,
to be used by metal fabricators.
that's right.
Cool.
Check out our classes each week. Come in and see for yourself what you can make here at Makerspace CT.
Thanks, everyone. Thank
Thanks,
you, Sabrina.
guys.
Good job.
Cool.